Hey everyone, this is question number 22 from chapter 6. This problem asks us if the speed of a car is increased by 50%, what factor does the minimum braking distance increase? So to start this out, just by reading the question, we see that we're trying to find a relationship between distance and speed. So immediately you should think of work, which is force times distance, and speed. We can equate work to the change of kinetic energy, which we know kinetic energy equals 1/2 mv squared. So immediately we can equate those two, and the equation we're going to be working with is force times distance equals 1/2 mv2 squared minus 1/2 mv1 squared. Okay, so to start this off, we don't have force yet, but we're not including we're just including brakes, and brakes works by friction, so the only force you're going to have here is the force of friction, as you see this free body diagram. And we know that friction, force of friction equals mu s times force of the normal. Again, see by the free body diagram, normal is just opposite direction of mu g. Sorry, not mu g, mg. So force of friction equals mu s mg. Okay, so now that we have that figured out, we can go ahead and fill in this equation. So the car is moving to the right here. This dot represents the car. The car is moving to the right, and the friction's acting in the opposite direction. So this force is going to end up being negative when we do that with the angle of the distance. So this equation is going to become minus mu s mg equals, your final velocity here is 0, so this whole term is going to go to 0, minus 1/2 mv1 squared. Again, this negative comes from distance is going to be d cosine, because the force is in the opposite direction. That's going to equal minus 1, because force is in the opposite direction of motion. Okay, so, forgot my d here, distance there. All right, so solving this whole equation for d, you get d equals v1 squared over 2g mu s. All right, so from this equation, we can get relative relationship between d and v, which is what we're looking for. So d is approximately v squared. So we are told that the speed of the car increases by 50%. So if something increases by 50%, you add half of that something to the whole, because it's increasing by 50. So the speed is going to increase by 1.5. So this would be 1.5 v squared. And that's going to give us that the distance increases by a factor of 2.25.